So hello everyone, myself Ayan, I will be the trainer for this particular course. So just a brief background about myself. I have total 8.5 years of experience into network industry across multiple domains. I have worked across multiple technologies, namely routing, switching, wireless and SD-WAN. And I will be the trainer for this particular course. Okay, I'll be muting every one of you all so that there is no disturbance during the demo lecture. Okay, so let me walk you all through the content that we are going to discuss in this particular course. Okay, so we will be discussing about Cisco Viptela SD-WAN solutions in depth in this particular course, and the code certification code for this course is 300415 ENSDWI. So in this course, we will be discussing about the architecture and the components that are used in the Cisco SD-WAN. So namely, there are three controllers. One is vBond, another one is vManage, and the third one is vSmart. So we will be discussing about these controllers in depth. And of course, there is the WAN edge routers, which is V edge and the C edges. So V edge stands for Viptela edge routers and the CH stands for Cisco edge routers. Okay. So the vBond is basically the authentication, manages the authentication and the orchestration plane for the SD-WAN fabric. When I talk about vManage is heart of the SD-WAN fabric and is responsible for managing the management plane. And when I talk about vSmart is the brain of SD-WAN fabric and is responsible for handling the control plane information. So we will be discussing about the deployment of these controllers in depth in this particular course. So the controllers can be deployed in two ways. One is the cloud deployment and the other one is of course on-prem. And we will be discussing the requirements and I mean how to deploy these controllers on the cloud as well as on the on-prem hypervisors or virtual machines. And in actual environment also these are deployed either on the cloud or on on-prem. 90% of the deployment is on the cloud and some of them host their controllers on on-prem. So we will be discussing both of them just in case if you have any clients that is hosting it on-prem, you got every aspects covered that is required. Okay, we will also be discussing about the certificates is one of the important aspects of any of the devices. So we will be discussing about the certificates, how to deploy that. Moving ahead, we will be discussing about the router deployment, how the routers will be deployed. So right from the scratch we will be discussing, I mean when we purchase a device, what exactly, after purchasing the device, what exactly is needed to bring it on the SD-WAN fabric. So this will be pretty much from scratch so that you have all the base covered to actually deploy it in any of the client environment. So we will be discussing what, I mean, after purchasing the device, what exactly is needed for onboarding. We will be discussing about the ZTP, PNP, and of course about the redundancy of these controllers. So one of the redundancy aspect is VRRP, and the other one is TLOC extension, which is specific to the SD-WAN in terms of redundancy. OMP is one of the important aspect of the SD-WAN fabric because the communication between the vSmart and the WAN edge routers mostly happens on the OMP. And OMP stands for Overlay Management Protocol, which this protocol is used in the SD-WAN fabric. Apart from that, we will also be discussing about the templates. Templates is yet again another important aspect of SD-WAN fabric, because any device, be it controllers or the WAN edge routers, templates are the features that is going which we are going to use to configure these controllers and the WAN edge routers. And we will be configuring OSPF and BGP as well in our lab. So talking about the policies, uh, there are policy is yet another important aspect of SD-WAN fabric. There are basically two types of policies. Let me show it to you over here. There are two types of policies. One is centralized policy and the other one is localized policy. And centralized policy is yet again divided into two aspects. One is control plane policy and the data plane policy. When I talk about localized policy, it is also again divided into two parts. One is control policy and the data policy. So we will be discussing about the centralized policy and the localized policy in depth, where and how to use it, so that when you do these labs, you will be having a brief idea in what situation what policy should be used, and what where and how it should be deployed and implemented. So this was about the policy, and using the policy you can actually manipulate the topology and the actual behavior of the data packets. So yes, this is one of the important topic in SD-WAN fabric. We will also be discussing about the quality of services and the securities in SD-WAN. In SD-WAN, one of the important factor is insertion, which is also called as service chaining. Uh, uh, this provides the security in the SD-WAN fabric. So we will be discussing about that as well. Apart from that, we will also be discussing about quality of service, which is in which we will be discussing about scheduling, queuing, shaping, and policing. Application aware routing is also one of the important topics in the SD-WAN fabric. We will be discussing about that as well. Moving ahead, we will also I will also walk you all through with the vManage graphical user interface, and where under which tab what features you will get. We will be discussing about that in this management and the operations part. Let me show you all about the labs that we are going to do in this particular course. Okay. So in this particular course, we are going to configure each and every WAN components. So right from the certification and right from the configuration, we will build this lab right from the scratch. So this lab will be from 0 day to day 2. So right from the scratch, we will be configuring it, configuring the devices via templates, pushing the policies, and we will do this in pretty much detail. So the vManage, we will first configure it via CLI. Any SD-WAN device, it has to be there has to be put certain CLI basic minimum requirements so that it can be then accessed via GUI. So we will do the vManage configuration, vBond configuration, vSmart, and edge devices configurations via CLI first, and then with the GUI as well. As discussed earlier, the templates is one of the important aspects in configuring SD-WAN devices. So we will be configuring each and every devices. We will be discussing about the different features that we have in templates. So if I have to give you brief about the templates, so templates is divided into two aspects. One is feature template and the other one is device templates. So we will be discussing about the feature and the device templates in detail, and we will also see how to use these templates to configure our SD-WAN devices. Moving ahead, we will also see each and every used cases that is being used in the industry as of now. And apart from that, we will also see the used cases that are not being used in the industry, but it is very much important from the technical concepts point of view. So we'll be discussing that in detail as well. If I have to talk about the main important policies that are used in the industries as of now is one is application aware routing, of course. The other one is hub and spoke. Almost each and every client or company is using hub and spoke topology. Then VEdgeNet is used for direct internet access, service chaining, and route filtering, traffic engineering, load balancing, TLOC extensions, which is yet again used for redundancy, and load balancing across multiple WAN edge router is one of the important aspect of SD-WAN fabric. We will be configuring and checking the doing the concept clearance of each and every features in pretty much detail. So let me show you all the lab that we are going to use for this particular course. So this is the lab that we are going to use in this course. Here we have our controllers that is hosted on the cloud. This is vManage, this is vBond, and we have two vSmarts for redundancy purposes. All these controllers are hosted on cloud, and we will be using a Linux machine to access vManage via graphical user interface. Here we have our spoke sites, branch sites. We will be using three branch sites, and this is the hub, the data center that we call. Each and every site has two links, one with the MPLS and the other one with the internet. This is the hub site where we have one WAN edge router. Again, it is connected to the internet and the MPLS. Here we have our firewall, which we will be checking in our service chaining lectures. So right from the scratch, we will be configuring each and every devices from a day zero perspective, be it the SD-WAN devices or be it the LAN side, VPN side routers. We will be configuring it right from the scratch. So you will be hosting this lab on the GCP. You will be getting 3 months of free. I mean, you can use it for free for 3 months and then again renew it. So I will walk you all through each and every step how to host it on the GCP and do the labs from there. Here we have the portal wherein you all will be getting the recorded lectures. So this is the portal where you will be getting the recorded lectures once you all enroll. Under the course section, we will be having a new course with SD-WAN name wherein you can get into it and then access all the videos from there. As of now, on the recorded lectures, we are having 40% off. So just in case if you all are looking for any other courses apart from SD-WAN, you all can head over here and uh, take the benefit of 40% discount that is going on. Apart from that, I'll give you all the link once the lecture is over. Apart from that, we have two YouTube pages wherein you all can head and check the contents across networking technologies, be it security, be it F5, be it SD-WAN, be it CCNA. I'll provide you all the link once the lecture is over. Let's start the demo lecture for today. In today's demo lecture, we will be discussing the difference between the legacy non-SD-WAN device and the SD-WAN devices and the control plane connections. So if talking about the non-SD-WAN devices, let's say we have a router. In non-SD-WAN devices, there are three planes: management plane, control plane, and data plane. Management plane is used for SSH, Telnet, GUI, HTTP, HTTPS access to this router. Let's say I have a laptop over here and I want to access this router via SSH. So these SSH packets are mainly handled by management plane. If I want to access this router via Telnet from this system, these Telnet packets are also handled by this management plane. And if I want to access it via GUI, again, it is handled by the management plane as name suggests. So if I talk about the control plane functionality, so control plane, let's say I have another router over here and OSPF is running between these two routers. Now, in order to form neighbor relationship with each other, they exchange certain packets, namely hello packets. And to build the topology, they exchange LSA packets, LSDB packets. So these packets are handled by control plane functionality. Okay, so the management functionality is handled by management plane. The control plane functionality is handled by control plane. Apart from these OSPF, be it BGP, EIGRP, ARP packets, all these packets are handled by control plane. And apart from that, data plane wherein the packets are routed from the source to destination is handled by the data packets. So earlier on, all these three planes used to reside on each and every devices. With SD-WAN, management plane has been removed from the device and it has been put onto vManage. The control plane has been removed from the device and it has been put on vSmart. And only the data plane functionality remains on the router. With this step, the efficiency of the device of the router to manage handle data plane packets has been improved. But management plane and control plane packets are equally important for a router and to form a network. So in order to get this management plane functionality, router forms a DTLS tunnel with vManage. It also forms a DTLS tunnel with the vSmart so that it can get management plane functionality and the control plane functionality from the vManage and vSmart respectively. We have yet another controller which is vBond, which is used for authentication. Any device, be it the controller or the edge routers, it has to be authenticated through vBond in order to get added into the SD-WAN fabric. Now, to reach now for the router to reach the vBond, it has to be, it should have some sort of configuration. It should know how and where to reach vBond. So there are three aspects wherein the router can reach to the vBond. One is via ZTP, PNP, wherein this router reaches to device.cisco.com, provides its serial number, certificate, and the chassis number and the organization name. After the authentication with the VBond will share the vManage and vSmart information. Now, when the router gets this detail about the vManage and vSmart, it also forms a DTLS tunnel with them. Once the DTLS tunnel is formed between the router and the vManage will push the configuration on this router via netconf protocol over TCP port 830. Apart from pushing the configuration, it will also start monitoring the health of these devices via ICMP echo and request and response. Apart from that, it will also check the health of the device, liveliness of the device via SNMP protocol using UDP port 161 and 162. Once this is done, the router will authenticate itself with the vSmart. And once the authentication is completed, it will form a DTLS tunnel with the vSmart as well. After the authentication, there will be some LAN or service segments behind the router. It will share all those service segments with the vSmart controller. Now, vSmart controller have these service segments from other branches as well. Now, since it is responsible for control plane functionality, it will calculate the best route for this router to reach any other branches and share it with the router. And this will be done via OMP protocol, and it uses TCP port 830 to share these details. Now, once that tunnel is formed, this is how the packets are sent between the controllers and the routers. Let me show it here. Once the tunnel is formed between the VH and the controller, this is the tunnel, and under this tunnel, they will share all the configuration, all the control plane information, all the management plane information. So just in case if there is any hacker on the network, and even if he tries to compromise, there is a tunnel, and all the data is uh, encrypted under this tunnel. So there is no way the hacker or any other person to get access to whatever the data that is being transmitted between the VH and the controller. So this is the main important difference between SD-WAN device and the non-SD-WAN device. So there are certain minimum configuration, as I said, which is required for this router to reach vBond, that can be done via ZTP or PNP. And apart from that, that can be done via bootstrap and via manually as well. So the important aspects that are required for this router is the vBond IP, the interface configuration, the organization name, the certificate, site ID, and the system IP. Once the tunnel is formed between WAN edge router and the controllers, this is how we get. So if we do show control connection history, from the one of the branch router, we can see that we have a tunnel with vSmart using system IP. It will also show on which port it is being used, via which interface, the interface name, the tunnel timing, how long it has been up in the upstate. Apart from that, we will also see the tunnel with the vManage and all the details of those tunnels. One important point, once once the VBON share these critical information with the router, it tears down the connection with the router. So if we see on the device, we will see it is in tear down state. Okay. See, earlier this branch router formed a tunnel with the V bond, and once the information was shared, this tunnel was teared down, and you will get the IP details and every details about this tunnel via show control connection history. So we will be discussing about the commands and all in pretty much detail during our course. So whatever we have discussed, I also have a notes about it. Let's go ahead to our notes and see. Cisco SD-WAN architecture decouples the control and management plane functions away from the WAN edge router. As we discussed, it couples away the management plane and the control plane away from the router. The solution implements these functions into centralized software-based controllers, which is vManage and vSmart, to oversee the entire network environment. Therefore, from the perspective of the vEdge router, the control plane and the management plane functions are remote services that are communicated to the devices. So the control plane functions and the management plane functions is the remote functions now. That is why each managed router must establish and maintain a secure control connections with each SD-WAN controller. As we discussed, that each routers should form a DTLS tunnel with the controller to get these necessary informations. The SD-WAN controllers are software entities that run as a virtual machines hosted either on-prem or on the cloud provider. So the controllers can either be hosted on the cloud or on the on-prem. Each controller plays a different role in the solution and interacts with WAN edge router through various protocols. As we discussed, vManage communicates over netconf protocol with the WAN edge router, and vSmart communicates with via OMP protocol with the router. For example, vSmart uses Cisco Overlay Management Protocol to communicate routing, TLOC, and service information among vEdges. vManage uses netconf to push configurations to devices, SNMP to collect data, and ICMP echo and reply to detect liveliness. To meet today's high standard for availability and security, each SD-WAN controller interacts with the WAN edge router in a secure and resilient manner. Every WAN edge router establishes one or more secured tunnel with each SD-WAN controller. As we discussed, each router will form a DTLS tunnel so that the data is shared in secured way. The tunnels are secured using a standard transport security protocol, either DTLS or TLS. Each control plane protocol such as OMP, netconf, SNMP, etc. goes through one of these DTLS tunnels. As we discussed over here, each information is passed from this tunnel itself, so it is secured. So there are two tunnels that can be formed between the routers and the controllers, that is DTLS and TLS. So DTLS stands for Datagram Transport Layer Security and TLS stands for Transport Layer Security. The only major difference between these two is DTLS operates on UDP and TLS operates on TCP, due to which TLS is a bit slower as compared to DTLS. Considering the latency information, since these devices need to reach cloud for each and every aspects, we are using DTLS so that this process is fast. So let's see that over here. Both protocols are very similar, and from a high level, they both serve the same goal to provide end-to-end transport security between the router and the SD-WAN controllers. The main difference is that DTLS uses UDP and TLS runs over TCP as discussed. This means that they handle packet loss differently. Of course, TLS relies on TCP for packet delivery. On the other hand, DTLS implements its own sequence number, fragment offsets, and retransmission, because UDP does not guarantee a reliable delivery of packets. In the end, TLS is slightly more secure and reliable but slower. DTLS is marginally faster and more efficient but less secure. However, the difference are so slightly that they are pretty much the same in practice. So by default, Cisco SD-WAN utilizes DTLS for all control plane communication because it is faster than TLS. The latency is essential when devices are managed remotely. As said, so if the controllers are hosted on the cloud, so latency plays a very important role in sharing the required details between the vSmart and the controllers and the routers. Let's discuss about the control connections to vBond between the vManage, between the router and the vBond. Once we power on the vEdge router for the first time in an unconfigured state, it tries to find the IP address of the vBond. vBond validates the identity of the vEdge, tells them whether they sit behind the net in an underlay. However, vSmart controllers oversee the domain, and most importantly, what are the IP address of the vManage and vSmart. So the main functionality of the vBond is to provide the IP address of the vManage and vSmart to the router once the authentication between the router and the vManage is done. This is the main functionality of the vBond. And once it shares these details with the router, it tears down the connection between the router and the vBond. One important point to note is, even if it is authenticated and this router reboots, it again has to authenticate with the vBond to get the vManage and vSmart IP details. In simple words, an unconfigured vEdge router needs to contact vBond to receive the necessary information required to join SD-WAN domain. However, how could a brand new configured router know the IP address of the vBond for a particular organization? So as we discussed, there are three ways wherein we can tell this router about the IP details of this vBond. One is via ZTP, in which the router will reach to devicehelper.cisco.com, provides its serial number and the certificate, and once the vBond validates it, it will give the vManage and vSmart IP details to the router. The other one is bootstrap configuration, wherein we can put this configuration in the USB stick and provide it to the router. And once it gets the vBond IP details, again, it will authenticate, it will share the vManage and vSmart IP details and tear down the communication with vBond. The third method is manually. We can log into this device. We will need someone on site to this router, give the system IP, site ID detail, organization name, vBond IP, and the transport interface configuration so that it can reach the vBond. And again, once it is authenticated, vBond will give the vManage and vSmart IP details and tear down the connection. Once the VH router finds the VBON's IP address, VH router tries to establish a DTLS control plane tunnel to the VBON IP address over each available transport interface. So if we have two interfaces, two WAN links connected on this router will authenticate using each of the interface. So in our example, so in our lab topology, we have this branch router and we have a connection from internet and via MPLS to the VBON router. So in this case, what will happen is VAN-Edge router will authenticate itself to the VBON over each of the interface. So in our case, branch BR Dubai will try to form a DTLS control connection to VBON over internet and MPLS as we discussed. It will authenticate itself over each control tunnel and find whether it sits behind a net device along any of the paths. So if these routers are sitting behind the net configuration, that will be collected by the VBON and shared to the vManage so that the controllers can know how to reach to this controller for uh, for the authentication. Post authentication, VBond will send back a list of IP address and ports of all the SD-WAN controllers, namely vSmart and vManage. Both DTLS control connections are then terminated because the VAN-Edge router does not need to keep a permanent control connection to VBond once it receives all necessary information. As I said, once all the necessary information is received, it will tear down the connection. VBond orchestrator will also inform vManage and vSmart to expect a control connection from this router. So as I showed, once this control connection is terminated, it will show as tear down, show in the tear down state in show control connection history. Okay, from BR Dubai, we can see that control connection to VBond is in tear down state. Let's check what happens between the WAN edge router and the vManage. So once a vEdge router receives the list of IP address of all SD-WAN controllers from VBond, it initiates a single persistent DTLS control connection to vManage. So in our topology, there are two WAN links, one via MPLS and other one via internet. So whenever this edge router gets IP details of the vManage and the vSmart, it will only form one tunnel with the vManage from only one interface. And whatever interface has the lowest number, it will try to form with that interface first. And if that is unsuccessful, it will try to form with the other interface. The VNH tries every transport network starting with the interface having the lowest port number, and it keeps the first successful established connection permanently. So in our case, let's say we have GI00 and GI0/1. So it will initiate the connection with GI00 first, and if that is successful, it will keep it as it is. And if that is unsuccessful, it will use GI0/1 to form the connection. So in our case, BR Dubai has two transport connection, one with the internet and one with the MPLS as we discussed. However, DTLS tunnel to vManage is established only via MPLS because it has the lowest interface number GI 0/0 as compared to internet's GI 0/1. If BR Dubai lost connectivity to vManage over DTLS connection, it would form a new one through the other transport connected interface to the cloud as discussed. When the WAN edge router establishes a control connection to vManage, the controller provisions its configuration and based on the device template attached to the VH. So as I told, we have to do all the configuration via templates. We will be doing those configurations beforehand. And once this authentication is done and the tunnel is formed, vManage will push the configuration via netconf to this WAN edge router under this DTLS tunnel. Let's see what happens once WAN edge router is authenticated to the vSmart. Following the successful DTLS tunnel to vManage, the WAN edge router initiates a persistent control connections to the vSmart controller over each transport interface. So in this case, WAN edge router will initiate a connection over both the available interfaces with the vSmart, and it will keep both of them. And apart from that, it will also create one OMP pairing with each other using the system IP. And under that DTLS tunnel, from that OMP pairing, it will share all the policies and all the control plane information to the WAN edge router. In our case, BR Dubai establishes a DTLS tunnel to vSmart through internet and another one through MPLS cloud at the same time. Technically, a single control connection to the controller is sufficient for a VH to receive control plane information. Still, VH keeps one permanent DTLS tunnel per transport interface for control plane resilience. When a VH router establishes at least one DTLS connection to vSmart, it starts a OMP pairing session. Just like the BGP and the OSP peers, WAN edge router initiates OMP pairing with each of the vSmarts. The router then advertises its local network. All these local networks are then advertised via OMP from WAN edge to the vSmarts. Then vSmarts, upon receiving the information from the controller, vSmart recalculates the routing information base based on the defined policies and redistributes to the routers to all other WAN edges using OMP updates. So in our case, let's say we have these two branches, BR Dubai and BR London. So once the OMP pairing is done between the vSmart from both the branches, this router will share all these details with the vSmart. This router will also share all these details with the vSmart. And now vSmart will calculate the best possible path to reach these subnets and give it to the BR Dubai router. Similarly, it will also calculate the best path to reach these subnets and give it to this branch so that they know how to reach these routes efficiently. Referring to a lab, we have two DTLS control connections to the vSmart controller over each transport, internet and MPLS. Although there are two DTLS connections to the vSmart, the router establishes one OMP pairing session with each other. Okay, so let me show you all the output of the OMP pairing and the DTLS connections from vSmart to the VH router. So this is how it looks. From the BR Dubai, we have an OMP peering with the vSmart IP 92, 99, 99, 99.12 and 13, which is a vSmart. Notice that this is the system IP of the device. Each device has the system IP, and the OMP peering between the WAN edge routers and the vSmart is done via OMP peering over the system IP. We can also see the state and the uptime, the site ID of the controllers as well. Apart from that, it will also show how many routes are received from the vSmart, how many routes are installed from the vSmart, and how many routes are sent to the vSmart. We will discuss about this in detail when we go through our lab sessions. So let's have a quick summary of the control plane informations. So whenever the whenever the WAN edge router is turned on, it finds the vBond IP via any of the three methods. It authenticates with it and get the vManage and vSmart information. And once that is done, this state is tear down. It will then form a DTLS tunnel with the vManage post authentication, get the configuration details via netconf TCP port 80. It will then again authenticate with the vSmart and get the policies and share the service routes information with the vSmart. It will have only one DTLS connection with the vManage. It will have two DTLS connections with the vSmart if we have two internet connections, two WAN connections. And if we have multiple WAN connections, it will have multiple connections with the vSmart, and there will be only one OMP pairing with between the router and the vSmart. So this is pretty much all about the control plane information. If you all have any queries with regards to this particular course, you all can ask now. Let me unmute.
Just give the mute permissions. And guys, let me just tell you, so we are starting this particular batch from 18th of January. It's a weekends batch and timing is 5 p.m. to 7:30 p.m. IST, Saturday and Sunday. And total duration of these particular sessions is 12 weekends. So total we have around 24 classes.